Hello guys, this is in ENGG studies lecture 3 on Laplace transform. Now we are going to see the remaining basic transformation formulae. We have seen first two in lecture 2, and this is lecture 3. We will continue with the third one. Laplace transform of e to the power at 1 by e to the power at by a. Sorry guys. Sorry, very much sorry. It should be 1 by s minus a. Now fourth one is Laplace transform of sin at is a by a square plus a square. Fifth one is Laplace transform of cosine at equal to s by a square plus a square is greater than 0. Sixth one is Laplace transform of sine hyperbolic at equal to a by a square minus a square. S should be greater than mod a. Seventh one is Laplace transform of cos of hyperbolic at s by a square minus a square is should be greater than mod a. Then moving on to the next one is linearity property. It states that if a and b are two constant, a, b are constants, and f and g be some functions of t, then Laplace transform of a ft plus b gt equal to a Laplace transform of ft plus b Laplace transform of gt. Then moving on to the next property. Oh, by the way, if you want to see how this comes, please write in my comment box. I think everyone knows this, so if you want to know, then please write it in the comment box, then I will surely make a video. First shifting property, Laplace transform of e to the power at ft. It states that if Laplace transform of ft equal to fs, then Laplace transform e to the t ft equal to f s minus a. Then from applying this we can find out many useful results. Applying this property we can find out many useful results. Such as first one is Laplace transform of EAT t to the power n is equal to n factorial s minus a to the power n plus 1. Second one is Laplace transform of e to the power a t sin t. Sin, let's say bt. For more generalized case, it will be b by s minus a whole square plus b square. 3. Laplace transform of e to the power a t cos bt. It will be b by s minus a, it will be s minus a whole square plus b square. Fourth one is Laplace transform of e to the power a t sin hyperbolic t equal to b by s minus a whole square minus b square. And fifth one, this is the last one, Laplace transform of e to the power a t cos hyperbolic bt, it will be sin hyperbolic bt, cos hyperbolic bt is equal to b by s by s minus a whole square minus b square. So let's now move on to some examples. We will solve some examples in both cases. So the first examples. First example. It is a very simple example. I think many of you can solve it. Sin 2t and sin 3t. So we can Laplace transform of sin. We have to find this out. So we can write it as Laplace transform of half into sin 2t sin 3. Then it will be cos minus cos 5t. So it will be half come out, Laplace transform of cos t minus half Laplace transform of cos 5t. So half is common. So this one is s by s plus 1 whole square minus a square, s by a square plus 5 whole square. So this is the answer. You can by the way, you have to further what will I say, you have to go further the calculations, but I am not doing this because it's easy. Every one of you can do it. The final answer should be 12s by a square plus 1 a square plus 5. So let's now move on to the next question. Next examples Laplace transform of e to the power 2t cos square t. How will we solve it? First, Laplace transform e to the power 2t. Now we have to cos square t, we have to write in cos t form. So how we will write it? We have to remove the square term. So we can write it as cos 2t plus 1 by 2. So from here, Laplace transform of two t cos 2t plus e to the 2t. So now by linearity property we can write that e to the 2t cos 2t plus Laplace transform of e to the 2t. This we can solve by first shifting theorem, first shifting property, half, and we know that the formula e to the power 80 cos bt. Remember this formula. This one. So we will solve it. So here a equal to 2, b equal to 2. So it will be s minus 2 whole square plus 2 square plus 1 by s minus 2. So do further equation. There will be further calculations. I think you can all do it. There will be some. We have to. What will I say? So add these two fractions. It will be your home task. I am doing what calculation you need to see. Let's now move on to the third example. We have to do Laplace transform of. It is a application of the first second lecture formula. So I think those who have watched my second lecture, they can easily do it. Laplace transform root t e to the power 2t. So let's now solve first Laplace transform of root t value. What will be t to the power half? So we see that t half plus 1 by s to the power half plus 1. So n tau n, so half, here n equal to half, tau half. Tau half value is root pi. So root pi 2 s to the power 3 by 2. But here we have to apply the first shifting property, because e to the power 2t is here, so it will become root pi by 2 s minus 2 3 by 2 to the power 3 by 2. This will be the answer. So let's now move on to the fourth example. Let's see. I think this one will be a good question. Laplace transform of sine hyperbolic at ft. we have to show that Laplace on sine hyperbolic at into ft is half if s minus a minus half if s plus a. So how we will do it? Think carefully. We know that sine hyperbolic at's value is e to the power at minus e to the power minus at by 2. So we will replace the sine hyperbolic value with half e to the power at minus e to the power minus at ft. So half comes out, Laplace transform of e to the power at ft minus e to the power minus at ft. So by linearity property we first write Laplace transform e to the at ft minus Laplace transform of e to the minus at ft. So Laplace transform e to the at ft, we have to use the first shifting theorem, which becomes f s minus a minus f s plus a. So hence proved. So let's now move on to the next examples. I think this will be a good problem. I think this is the fifth example. Cos root t by root t. Laplace, we have to find the Laplace transform. First we have to know the expansion of cos theta value. Cos theta expansion is 1 minus theta square by 2 factorial plus theta to the 4 by 4 factorial minus theta to the 6 by 6 factorial plus dot 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 dot. So cos root t expansion will be 1 minus t by 2 factorial plus t square by 4 factorial minus t cube by 6 factorial plus dot 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 dot. Means dot 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 means I mean that this is my what will I say, the wrong pronunciation. It will be, it goes on and on. So cos root t by t, root t becomes t to the power minus half minus t to the power half by 2 factorial plus t to the power 3 by 2 by 2 factorial 4 factorial minus t to the power 5 by 2 by 6 factorial and goes on and goes on. So we have to find a Laplace transform of this. So it will be Laplace when we are using linearity property and linearity property and writing it in this way. It will be minus Laplace transform t to the 3 by 2 by 4 factorial minus Laplace transform t to the 5 by 2 by 6 factorial plus dot dot dot. Sorry, it goes on and goes on like this. So Laplace transform t to the minus half means n is not positive integer. Those who have seen my first lecture, they know this. Second lecture, they know this. I think n is equal to minus half. So here gamma function will be used. So it will become tau half by s to the power half minus tau 3 by 2 by 2 factorial plus tau 5 by 2 by 4 factorial minus tau 7 by 2 by 6 factorial. And by now solve it. I am doing it directly. I know you guys can do it, so I am doing it directly. Root pi by 2 will root pi pi by s will come out. Oh yeah, here will be s 3 by 2, s 5 by 2, s to the power 7 by 2. Comes out means I taken it is as common. 1 minus 1 by 4s plus 1 by 2 factorial by 1 by 4s whole square minus 1 by 3 factorial 1 by 4s cube, and it goes on to root pi by s. And we have seen that it is similar to e to the power t expansion. So we will write it as e to the power minus 1 by 4s. So now guys, I am halting this lecture. I will make another video of continuation of this lecture. Please see it. Thank you guys, and please subscribe the video. Please subscribe my channel and like it if you all like. Thank you guys again for watching it.